messages, codes, ciphers. They're all based on encoding and decoding. Today, we're going to be learning about encoding and decoding. What is it? What is it actually? We're going to be learning about tuples, okay, as they're important to encoding and decoding messages. And we're going to be learning about a rotary encoder. What does a rotary encoder do and why? Join me on this MEG segment. I'm your host, Zachary Anderson. Howdy! So we're going to be learning about three different things. We're going to be learning about tuples, we're going to be learning about encoding and decoding, and we're going to be learning about this little guy, the rotary encoder. Now the way this thing works is there's a couple little switches in there, and as we turn it, we can hear that clicking sound. And every time we turn this thing, it's actually encoding the increment or decrement of an angle into little pulses that an electrical circuit can understand. And these have a variety of different applications. They can be used for incrementing or decrementing, say, the tuner in your radio, the volume of an amp, or possibly even lighting. So let's first talk about tuples. What is a tuple? Well, a tuple is an ordered list. And we've got some different statements down here, some different tuples, okay? So our first one here, we have 1, 2, 2, 5. And for a tuple, we care about the order, okay? We care about the order of the elements. So 1, 2, 2, 5 is not equivalent to this tuple here of 2, 1, 2, 5. Can we see how the 1s and 2s have been switched? So the order is very, very important. So these are two separate tuples. Not only is the order important, but also the number of instances of each element. Okay, so for example, 1, 2, 2, 5 is not equivalent to 1, 2, 5. Okay, they're different. Can we see that there are two 2s here and only one 2 there? Okay, so that is two very important pieces of a tuple. Okay, is the order and also the number of instances in your list. Okay, but we're going to talk about a special kind of tuple, a word. We're going to say howdy, hello, hi, howdy. So language is actually an example of a tuple. Okay, it's an ordered list of symbols rather than numbers, and we can use howdy as our example here. Okay, so when we're encoding things or decoding things, we're actually switching between types of tuples. So we're going to define encoding as taking a generally understood tuple and converting it into a less well-known tuple. Okay? And we're going to define decoding as taking a less well-known tuple and converting it into a more generally understood tuple. And as an example, we're going to use howdy. Okay? So here we can see howdy. We've got five elements, right, in this ordered list. We've got H, O, W, D, Y. Okay? And I'm going to convert this, I'm going to encode this into a set of numbers that I know, but you don't. So this is an example of how I'm reducing that generalized understanding, right? Because I have some information that you don't, right? So less people are going to understand what this is. And this is actually used in a variety of transmissions between governments and military for keeping things very secret, very quiet, right? We want to send a message to somebody, but we don't want other people to hear what it is. We're going to encode it, we're going to encrypt it so that it's harder to understand. But sometimes we do that so that it's easier to understand. So it's a little bit different from encryption, but that is one purpose of encoding. So here I have encoded it into a set of numbers, 9, 16, 24, 5, and 26. Okay, and you'll notice that 26, that's actually the number of letters that are in the alphabet. So the way that I've encoded this is in a particular way. So what I've done is I've actually assigned a number to each letter of the alphabet. A being 1, B being 2, C being 3, all the way up to Z being 26. And what I've done is I've taken each letter in howdy and I've shifted it over by 1, okay? So for example, Y, I've shifted that to a Z. D, I've shifted that to an E. W, A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, V, W, X. So I've shifted that to an X, and so on and so forth. And then I've taken that letter, shifted over by 1, and I've converted it into its number and shown it up here, right? So let's take Y for example. So to encode this, I've moved y over 1, so it's z, and then I converted it to its number, 26. So 26 is y, right? Same for D. So D is normally the 4th letter. I move 1 over to E, and I convert it to a number, 5, right? And so I've done that for each of these letters. And you're gonna do the opposite to decode this message, okay? So if we're trying to understand what 26 is, right, we're gonna convert that to a letter, it would be Z. We're gonna step back one letter in our set of the alphabet, and that's how we get Y. Okay, so that's how we encode and decode information. Now here we can see a rotary encoder. Okay, so this is a diagram of a rotary encoder, and there are 2 ways that we can turn this thing. Okay, we can turn it clockwise or counterclockwise. All right, and we've already seen an example of a rotary encoder. And as we turn this thing clockwise, you can see that there are some white dots and some red dots here, okay? So these white dots, these are gonna represent our signal A, and these red dots are gonna represent our signal B, okay? And you'll remember that there was some clicking when we were moving that rotary encoder, and that clicking is actually some switches, okay? So switch A is going to open or close before switch B. Okay, so as we turn this thing clockwise, switch A is always opening before switch B. And as we move counterclockwise, the opposite is going to happen. So switch B is going to open before switch A. And that's how we can tell which way that we're turning around. And as we turn this thing, we're actually incrementing or decrementing the angle, okay? So if you imagine that I had a hand of a clock here, and I'm turning it clockwise, you could say that I'm incrementing the angle. And if I was turning it counterclockwise, you could say that I was decrementing the angle, okay? So we can encode that incrementing and decrementing of an angle into pulses, and that's what we're doing here. So that is the purpose of the rotary encoder, is to actually convert the incrementation and decrementation of angle into pulses, okay? So here we can see A comes before B, so A goes high before B, A goes high before B, A goes high before B. So that means that we are incrementing. And here we can see B goes high before A, B goes high before A, B goes high before A. So that means that we're decrementing. So now let's take a look at this cool simulation of what a rotary encoder really does. So here we can see that this is a programmed microcontroller, and it's simulating our rotary encoder. And we have 2 buttons here to act as though we're turning this rotary encoder. So you can imagine as I turn this thing, that's the equivalence of pushing the button. And every time I turn it up, I'm going to be incrementing the angle. And as I turn it down, I'll be decrementing the angle. And on the right side here, we can see 2 LEDs, and those are going to represent the pulses that we saw on the board. So let's go ahead, let's run the simulation, and we can see what's going to happen. So as I click increment here, you can see first we have A that goes high, and then we have B that goes high. So we'll do that again. So you can see that the A LED here lights up just before the B LED, and then it turns off just before the B LED as well. So there we go. So there's our pulses on A and B, and that's for incrementing. And as I decrement, you can see it goes the opposite way, right? So B is lighting up before A. B is lighting up before A. And so this is one way that we can encode these rotations into pulses that can then be understood by circuits. So we can actually tell what is the actual rotation of a rotary encoder based off of these electrical pulses. So your challenge for this video is to decode a message. So you remember the rule that we used to encode howdy? Well, I want you to use the same rules in reverse to decode the following message. So here we go, I hope you're ready. So 14, 2, 12, 6, 10, 20, 3, 6, 20, 21. So that is your message to decode using the method in reverse that we used to encode howdy. So I hope you enjoy this challenge. So we learned a lot this segment. We learned that tuples are an ordered list where the number of instances are important, and of course the order of our elements and instances are important. We learned about encoding and decoding, how encoding is taking a generalized, understood tuple and converting it into something that's less well understood. And then decoding is going back again. We also learned that a rotary encoder is encoding the increment and decrement of angles into little electrical pulses that can then be understood by a circuit. So I hope you've enjoyed this segment. I'm Zachary, and I'll see you in the next one.